All right, give everybody a couple more minutes to get in. All right, well, I guess we'll go ahead and jump in, get started. Let's see. Okay. So, who can remember what we were discussing last time, a whole week ago, before we got out for break? What were we talking about? Does not bode well for the day. All right. So we were talking about this new mathematical object called vectors. And a vector is an arrow that goes from one initial point to what is called a terminal point. And we'll call this point P, point Q. But it's just an arrow that goes from one to the other. And the way we define it to be a vector is with this little symbol right here. So it's starting at point P, and it goes to point Q, and this arrow over the top means that it is a vector. So we started talking about what qualities these things have, because the first thing that we need to be able to do in science is, or in math, is tell whether this thing and another thing are the same or how they're different, So we need to be able to compare and contrast vectors. So, like I said, we need to figure out, well, what qualities make a vector. One of those qualities that we talked about was the length of this line. And if you're going from some initial point P and some final point Q, how do you find the distance between point P and point Q? How do you find the distance between point P and point Q? Somebody, anybody? Guess I'll wait. It's going to be a long class. How do you find the distance between 2 points on a graph? Well, okie dokie. Okay, so the magnitude of vector PQ is just the distance formula applied on the 2 points at the ends. So the difference in the x component of that point and the difference of the y component of that point. There's another thing that becomes important when comparing two vectors, and this is the other quality that we started talking about at the end last time. The first one is the magnitude of length PQ And the other one is the direction. Depending on how you want to talk about this, it's kind of up in the air, but we usually use, because we've been talking about triangles, we usually use trig to talk about the direction. The other one that makes sense to a lot of people with this is the slope. But the idea is it's how far up is it going versus how far to the right or left is it going. So in some sense, you could kind of think of, or at least start with this idea of slope, which is the change in y over change in x. Now, it's not quite what we're going to go for, but that is what we're going to do for right now. So for two vectors to be equal, they have to be equal in all of their properties. So they have to have the same magnitude, which is the length of the arrow, and they have to have the same direction, which is which way that thing is pointing. So the way we determine direction is by angle. And one way we said is that slope thing, but we like angles in here. So let's try and come up with an angle that tells us everything we need to know about this vector. So the way we define it is on a x, y coordinate system. If we draw our vector, angle that we care about is right here. So this has a few different possibilities that you could talk about it in, but you might hear polar angle or full angle, natural angle, depending on what context you're in. But this tells us the direction. So the angle is measured from the positive x-axis counterclockwise to the angle that you are looking for. So that is theta. So what's another way we could build theta? Well, if we have this vector, then we have its initial point and we have its terminal point. Well, its initial point is 0, 0. It's at the origin. So its terminal point is just x, y. So somebody please tell me, if I know x, y of this point, how can I find this angle? Should be a fundamental idea of this class by this point.
I'm trying to find the angle.
Yeah. So what is x? We have, like I said, we're given x, y, which is the location of this point. But what does x mean? What is x?
X is the point on the x-axis.
Okay. A little bit more to that. What do you mean it's the point on the x-axis? This point is not on the x-axis. It's up here.
It's like
What does x tell you?
tells me
You're on the right track, but I need that kind of vague where we left.
I don't know.
Well, I appreciate you trying, unlike everybody else. X is how far you have to travel in the x direction to get to the point. You also have to travel in the y direction, but you still travel in the x direction. So x is this distance right here. What is y?
The point you have to travel in the y.
How far?
How far you have to travel in
You
y?
have to travel in the y direction to get to that point.
Vertically. No, yeah, vertically.
So if we have, what did we draw here?
A right triangle.
A right triangle. So what do I know about right triangles that can help me get theta?
One of the right angle is 90 degrees.
Well, we know the right angle is 90 degrees.
And that doesn't it equal 180?
If you add up all the angles, it's 180. But if I want this angle, and I have this side, and I have this side.
Oh, Pythagorean theorem, right? No, not Pythagorean theorem. Find that.
Why?
It's something else.
So is this side opposite the angle, adjacent to the angle, or the hypotenuse of the triangle? Is y opposite, adjacent, or hypotenuse?
Adjacent? What is the opposite?
It's opposite because it's the one that's not next to this angle. So is x Opposite, adjacent, or hypotenuse.
Opposite. Wait. What did you?
X is adjacent. So, what is a fundamental identity that relates an angle and the opposite side and the adjacent side?
Tangents? Wait, no.
Tangent.
Okay.
Head on. So, tan theta equals opposite over adjacent. Or if you want the angle, you put the tan on the other side. So this is what I meant by it's similar to the slope, because what would the slope of this arrow be? How do you find the slope of something?
Divide the y.
So it's the change in y over the change in x. Since it started at 0, 0, the change is just, the change in y is just y, change in x is just x. So the slope of this thing is y over x. So this is what I meant by it's close to the slope. It's related to the slope. It's just, we need it, we would like it in an angle, because we like angles in this grade. So it is essentially the inverse tangent of a slope. All right. So the direction, which is this angle, is the inverse tangent of the slope. Let's see. So yeah. Okay. So we've got vectors, and they have a magnitude, which is a length, and they have a direction. So there's a slightly different way of talking about it, and it's related to this thing right here. So we have one camp. You could define a vector by its length. We're going to call it r for a second. And theta. So this is magnitude and direction. So some of y'all may notice that r and theta are what are called polar coordinates. So let's see if I can get a picture. Polar coordinates, instead of defining things in X and Y directions, they define things in where something is, depending on its angle and its distance from the center. So let's see. Let's look at this one. No, that's not one. All right. So we have r and theta. So you define where something is out in space based on how far away it is from the middle and where around it is. So for reference, this line right here, or this little circle, everything on this circle is 1 unit away from the middle. And then you use theta to say where on that circle is it. So if the angle is 0, then it's right here. Let's zoom in a little bit. If the angle is 0, it's right here. If this would be an angle of 45 degrees about, 90 degrees, 135, 180, so forth all around. So this is a different way of describing coordinates. This is polar coordinates. But it's still related to the same idea, where you have a magnitude and a direction. So this is, there is also another way of talking about vectors, and that is what's called component form. I like component form because for the most part, it makes most of the math that I do easier. But just know that they're both valid and you can always go between the two. We'll talk about that a little later. But a component form just splits up the vector into two fundamental pieces, kind of. So for this, we have an X component and a Y component. The way we write this is the vector equals, we do a little caret bracket, and this is the X component, comma, the Y component. It's basically, this vector goes how far in the X direction and how far in the Y direction. This is one of the reasons why I like this, is because it's something that you guys are mostly used to. You deal with X and Y coordinates all the time, more so than these polar coordinates, which I just erased. So, yeah, we have this thing called component form. And it's a little bit simpler to talk about because it's as basic as this this little picture right here, where the length in the x direction is the x component, the length in the y direction is the y component. These are generally written a little bit differently. The name we give them looks like this. Give the letter of the vector, and you put a subscript of whichever one it is. So we have the x component, the y component. So we have all of these different qualities, but they are all linked together by this picture. This is what I want you to remember, to take home. If I give you any two of these things, I guess I'll write them all together. So R theta V1. If I give you any two of these things, you can find the other two. And it's all based on this little relationship. So what are the equations that relate these things? Actually, let's keep our letters more streamlined than this. So there's a relationship that relates R, Rx, and Ry. What is it? What is the relationship for R, Rx, and Ry? What is it?
Dr. Dean, what I'm confused on, what are we trying to find?
So let's clear some stuff out. So R is the vector, the green arrow. We said there's two ways of defining that thing. You can either talk about its length, which is R, and its angle, theta, or you can talk about it in terms of its components, which is how far it is in the x direction, Rx, and how far it is in the y direction, Ry. What is the relationship between R, Rx, and Ry? Relationship means equation generally. Come on, y'all. So we're gonna have to start off next time. We're about to get kicked off. Not asking a bunch. Something everyone in here should know.